Today I will solve concert tickets of CSES problem set. So let's jump to the problem statement. There are n concert tickets available, each with a certain price. Then m customer arrive one after another. Keep in mind. Okay. Each customer announces the maximum price they are willing to pay for a ticket. Okay. And after this, they will get a ticket with the nearest possible price such that it does not exceed the maximum price. So we want to sell like to the customers such that it is as near as possible to the maximum price they are willing to pay. Okay. And we so let's see what are the inputs. We have N and M, which says the number of tickets and the number of customers. Okay. One array, which gives the price of each ticket. Okay. And the last line is array T, which is the maximum price for each customer, like the maximum price the customers are willing to give. Okay. What do I have to do? Print for each customer the price they will pay for their ticket. Okay. And after this tickets, like if they have bought that particular ticket, it won't be available for other customers. Okay. And if a customer cannot get any ticket, print -1. Okay. So let's parse this question. First of all, the customer arrives one after another. Okay. Customer arrives one after another. This means we cannot do sorting here, like we have to go in the given order. Okay. And what I have to do, I have to find, like, let me take some test cases as well. Let me take this only. uh, okay, we have n equals 5 and t equals 3, and the customers, the price of each ticket, and the customer's maximum price. Okay. So first of all, we will check for 4. What we have to search, like we have to find for 4 we have to find maximum number greater less than or equals to 4, less than or equal to 4. Okay, for similarly for 4, 8, and similarly for 3. So what's the for what's the answer would be for 4? We will find like for 4, like we don't have 4 here, so we will decrease it, and then we will see 3. So for 4 it's 3. Okay. And for 8, what would be there? For 8 it is for 8 it's 8 only. And for 3, for 3, first of all, notice that I have already bought ticket for 4, so we, which is price 3, so we have to first erase this. Okay. These 3 and 8 are already bought, so we cannot again like buy this ticket. So we have to find another 3 if available or less than 3. So here it is not present, not 3 is present, another, not another 3 is present, not neither any number less than 3 is present, so we will print -1. Okay. So now what we can do, do you like think what it is something, this particular statement less than or equals to particular number, we can select this full maximum number less than or equals to 4. Do you think do you heard of similar things like that? Yeah, we have we have upper bound and lower bound. Okay, so we have to upper bound and lower bound. Okay, so what does that mean? What does the lower bound means? Lower bound means a number which is like, what does lower bound return? Lower bound return index of a element which is greater than or equal to a given number. Like if we have to find the lower bound of 4, so we it will return the index of number which is greater than or equal to 4. Okay, and what does upper bound do? It returns the index of a number which is greater than the given number. Okay, that's the only difference. So let's move forward. Like what against now we have to decide like which to use. uh, According to this statement, it seems like we can use lower bound, so let's check it also. So what does uh, for 4 suppose, okay, so for it will give any number less greater than or equals to given number. Okay, so but here it's less than only, not so we have to consider that. Okay, so for lower bound it would be lower bound of 4 would be 5. Okay, so before that you also must know that the data structure which we in which we are applying the our lower bound and upper bound data structure must be sorted one, must be sorted. Okay, so let me sort this also, the sorted one. It's 3 5 5 7 8. Okay, so lower bound returns the index, or you can say iterator, but I am like considering it as index only. So it will return 1, which is the index of 5. Okay, and what would the upper bound return? Upper bound of 4 would be also 1. Okay, yeah, there's no issue. Okay, so let's move to something which is okay. Lower bound of 8. Lower bound of 8. What would be the lower bound of 8 here? So lower bound of 8 would be the we have 8 here. Okay, so 0, 1, 2, 3. So it would be 3. And what would be the lower bound of 8? Sorry, upper bound of 8 would be 8 would be it would be what it would be? It would be like index which is greater than like the array dot end, it would return. Okay, Now let's analyze this, and we can, from this only we can decode that which to use, whether we will use lower bound or upper bound. See here, lower bound of 4 is here 1 and 1. So like we are getting this only. So we cannot use this. Okay, we cannot use this. Why? So we have to move just a step backward. Okay, one step backward in lower bound. One step backward. Similarly here, we have to move one step back. One step back. But here we are getting 0, 1, 2, 3, 4. 0, sorry, it would be 4, not 3. So here we don't need to move. No need to move back. And here we have to move again back. Just one back. Move one step back. So here you can say there is uniformity in there is uniformity in upper bound. Like we have to move one step back every time. Okay, so it would be better to use upper bound rather than lower bound. We can also directly say like here we have to find less than or equal to given number. Okay, so what would be the opposite of that? Greater than or equal to. Okay, so that's why I am using upper bound. So for everything I will use upper bound. Okay, so let's code it and we will see some of the logics as well. So let me remove these as well. We have to like n would be there here, m would be there, c n and m. Okay, now we have to take input of the price of each ticket. So before coming to code, let me tell something more. If any particular ticket is bought, okay, and if any ticket is bought, so we have to remove that from our data structure. So erasing and also finding the given number, like we can find through upper bound and lower bound, so it would be log n. Okay, but erasing is the problem here, because erasing will take more time. In a vector, if I am taking a vector as my if I am taking a vector as my data structure, so what would be the better one? So we need sorted as well, so we need a sorted data structure. Okay, for sorted data, so which are the sorted data structure? Map, multi-map, set, multi-set. Okay, these are the, and there can be some more, but I am recalling this only, these only. So can we use map? Like we really need to use map. First of all, like we are getting index through lower bound and upper bound, so we do not need index through map. So here we map is not a suitable idea. Also, we are not counting the numbers, so also map is not a useful. So we will move to set. So what do we use? Set or multi-set? Here multiple tickets can be there, so we have to use set, multi-set, sorry. And also what does multi-set do? It does it keeps the array in sorted order, and the find like erasing the number would be much more convenient. Like much more efficient, like it would be log n, but in a vector it would be of n. So there's a problem in vector, so we are using multiset. So here I will st dot insert x. Okay, and let me define here multiset. Okay, I have defined and I have inserted, so this would be login operation. Now we have to take the customer maximum prices also. So for int I equals 0, I is less than m plus plus I. Okay, so C in T. So now for every customer I have to find its lower bound minus upper bound minus one step back. Okay, so auto it equals what are the st dot upper bound st dot upper bound of t. Okay, so suppose we have got the upper bound. Now what are the cases can be there? If it gives it dot like the end one, like st dot end, so we have to move one step back. If it gives any number which is like in middle, it gives any element in midway in middle of the set, so we have to move one step back. But if it returns it is st dot begin. Okay, not that. If it returns if it returns, suppose for this only. Okay, what will the upper bound of 3 would be written of, because here we have 4 have been used by 3, sorry 3 have been used by 4, so we have to erase that. Now what would be the upper bound of 3? It would be 5, so it's the first one. And if it is the first one, like if return if upper bound of any element is st dot begin, that means we do not have any number which is equal to or less than that given number. Okay, so we do not have any number less than or equals to 5. So that's the case when the like our tickets cannot be given, like tickets cannot be sold to that particular customer if upper bound is st dot begin. Okay, if it's the first number. Okay, so let's move to the code. First of all, if it equals st dot begin, so I will do cout -1 and l. Okay, else what I have to do, it minus minus, I have to move one step back as I have already said you. And what I have to print, cout star it and l. You have to print in same, sorry. Okay, so we have to written in different lines, so and l is good. Okay, also here I have in we cannot like If condition is not giving any ticket, so we cannot erase anything here. But this else condition is giving ticket. Okay, so if it is given ticket, after giving the ticket we have to erase that ticket. So st dot erase id. Okay, so that's it. I think the code should run. So let me take this and try to run the code here. 38 minus 1. Okay, I am, it's correct. So let me try to submit it. Mhm. Yeah, so it's, so what did we learn in this code? First of all, we have we have used upper bound. We have learned the concept of upper bound, lower bound. So if we get to if we decode that, we have to find similar, like number less than or greater than equal to, like this way. And the we have sorted data structure, or we need to sort the data structure. So upper bound is the best thing. Okay, so that's the first thing. And also, why did we use multiset? Because erasing here would be a better option instead of erasing in vector. So that's the best idea. That's a better one for erasing it. Okay, so that's it from my side.